Hello, welcome back to my bench. If this is your first time here, greetings, welcome. My name's Dave. I work mostly on radio station equipment, especially the older stuff. Some of it newer, but mostly older. And we do full-on repairs here down to the component level. So don't forget to register if you're interested in this kind of repair. Today we have a TC Electronic M1XL dual effects signal processor. I've never actually seen one of these. I've heard of them, but I've never seen one. Nice little box, pretty. Looks like it's well made. All kinds of buttons on the front. I've not looked up how this works or anything. I presume it's used for just adding effects in line. It's got a input level, a mix percentage of mix, and effects balance, just like on a board. It's got routing and I/O and tap and utility. I don't know what half of this stuff means. Bypass, that's good. Recall and store, so you could program it for individual, I guess, the ways you want the station to sound. Well, this goes in the station. This probably is more of a high-end prosumer type of deal rather than professional station stuff. But you know what? A lot of stuff now, what we call prosumer, is just fine for broadcast, because the stuff is built a lot better than it used to be. Well, okay, let me take that back. It's not built better than it used to be, but the stuff in it will last longer than it used to did, if you know what I mean. They're not built better. Most stuff today is just consumer and prosumer stuff is built horribly. But with the advancements in electronics that we've had, they last a long time. So we'll take a look and see what's in this. That's the front. Got a big old display here. And on the back, we've got what? Let's see. Turn it around so you can read it too. Here's your balanced inputs. This gives you a hint that it's kind of prosumer. I mean, it's got XLR inputs and outputs, and no other way to get into and out of it. So, yep, there we go. Except it does have digital SPDIF. So, and it's got MIDI in, through, and out, and a pedal. Ooh, that's a pretty little connector there. And a pedal for I don't know what. Probably turn it on and off and make the effects work. But like I said, I don't know anything about it. You don't need to know how something works to fix it, actually, most cases. Although, if it's real digital signal processing and you can't get a manual with waveforms in it, you're sort of stuck. It goes 100 to 240 volts, 50 to 60 hertz, 15 watts. So we know it's going to have a switch mode power supply inside of it. See if we can find a date code on this thing. No. No. It is made in Thailand. And it says professional audio equipment. Alright, well, let's plug it up and see what it does. This was sent in saying it didn't work. So, there's a description for you. It is off. It's on the current limited power supply over here. So, we'll turn it on. Watch the light bulb. Nothing happens to the light bulb. And nothing happens to anything else when I turn it on. And it is drawing 3 watts. And it's drawing 3 watts off. So it ain't doing nothing. Okay. Well, test 1, abject failure. How do you get this apart? Well, let's start with the obvious. Coffee first. Radio station engineers live on coffee. It's just the way it is. Those are, okay, regular Phillips. Pretty little box, all rack mount and everything. Well, that is screwed right into the side, so it looks like you got to take the rack mount wings off of it. What have I got over here? Looks like about the right size. Yep. Wow. They didn't want those to fall out. I didn't mean to say that you can't fix something that's a digital signal processor. I'm just saying if it is in the digital signal area where it goes from D to A and A to D and all that kind of stuff, you're without the right equipment and the right and the waveforms and everything that you need, you're not likely to be able to. So, well, the front comes about that far and stops. All right, and the top, oh, well, there's 4 screws back here. Let's take a look at those. Anyway, don't get discouraged if you go in to fix something and you can't. There's just some things you can't. I can't. I mean, I've been doing this a long time. That's why I more or less stick to older stuff. I've got the equipment to fix it, especially the RF and RF and old audio gear. And you just can't be everything to everybody. I bet you dimes to donuts, come back here, that we're going to have to take all these screws out for these XLR connectors. Also, and these are the ones with 4 or 2 screws each, so yeah, they wanted to make darn sure this thing didn't fall apart. Wow. Yep. All right. Wow. Huh. And this thing too. Not the right size? Maybe. Yep. Okay. Well, that's different. That's a different sort of instead of going around the outside, this one goes inside. And a couple of washers here, a washer and a little black. That's don't believe I've ever seen one quite like that. So is that it? Hey, that's it. Okay. Ooh, well, not terribly impressive. All the magic is done here, of course. And I don't know, what do we got on here? Let me take a look. So, 5532s. A bunch of them, of course, inputs and outputs. What is this? CS8414. Don't know what that is. If I can find these things, I'll put them up on the picture. Here's your DSP. DSP B56362A. Okay. There's a, I don't know, that's a one I've not seen before. A42LO616. That's memory probably, or something like it. I don't know, I could be completely wrong. And C67130A 11. Or AT1, yeah. I don't know, just and a ROM chip built in, looks like. So, well, that's glued down, can't get that off. All right, well, and of course the ever-present, gotta have them, switch mode power supply. Alrighty, well, let's see. Let's take some voltage measurements, considering nothing is happening. Well, I think first of all we need to check and see what we got as far as if the fuse is any good. And bring up the meter. Be nice, they might be able to see it. Where's meter? Hello? Meter. All right. And come on. So yes, the fuse is good. It's got goo. I hope this is not what I think it is. It does not appear to be. No, it doesn't appear to be. It's got that dark goo stuff here. But it doesn't appear to be conductive. All right. Some of it is, some of it isn't. You don't just have to rip into something and tear it all apart, because this would be fun. This has got wires going into it that are very, very fine wires coming out of this transformer, so that would not be good. All right. Let's go back to voltage. And it says right over here, plus and minus 15 volts A. And that's all it's feeding. And what is this? All right. So 3 volts, ground, and 5 volts. All right. Well, I wonder if this ground, is the same as this ground. By 33 ohms, probably. So, might be able to just stick that there. I don't know, we'll find out. All right. Plug it in. Turn it off. Plug it in, turn it on. And turn it on. Still drawing nothing at all. Well, let's see what we got here. We got 5 volts. We got 4.99. That's good. We got 3.3 volts. That's good. We got minus 15 volts. That's good. That's A ground. And we got, what? That's supposed to be plus 15 volts. We got 6 volts and where plus 15 is supposed to be. So we're missing a voltage. Let's take care of that first. which would probably be, well, I'm sure it's over on this thing. So how does this come out of here? Well, that doesn't help any. No, it's okay. Little one. These are all Torx. These different? Nope, same size. I can tell by looking at this thing, I know it's screwed into the base of this board. And of course the two you can't get to very well. Well, this one's easy. Okay. That it? Yes. Wow, cool. All right. Touching carefully to start with. And doing voltage measurements across big capacitors. Oh, nothing. That's good. So it drains it. Got a couple of guys down here. Nothing. Nothing. All right. So we can touch without going poof. What do we got? Well, let's see. Pretty simple power supply, actually. It's got hot end, fairly good protection, rectifier. We know this is working because we got the rest of the voltages. And it looks like we got 3 voltage regulators over here. 3.3 is probably that guy or something close to it. Probably. I don't know how they got it. I can't find a schematic on this. We're just winging it. So what do we got here? That is a 7915 for the negative 15 volts. This is a 7805 for the plus 5 volts. And this is, with a heatsink on it, a 7815. So that's your plus 15 volt regulator, and that's the one we don't have any of. And this one's got a little bit of discoloration. Can you see that? And it's the one with the heatsink. Shoo. Well, we'll pull this out of here and replace it, of course. Gotta wait for my solder sucking weapon of mass destruction to heat up. I'll be back. Okay, I'm back, and the thingy here is all heated up. Hope it's enough. Maybe not. Eventually, I'm going to get a new one. That one's just not quite powerful enough. So, old-fashioned. Well, let's try the two-handed method here. Now. Okay. Kerchunk. Sit. Gotta put on my geek glasses here. Does not want to stay still. And there's really no good way to keep it still. Okay, maybe there. Nope. Back to basics. I don't want to unscrew this whole thing and take it out. That would be silly. Come on, thank you. Give it a little bit of flux. I know this stuff's got flux in it, but it works better if you add flux to it. Okay, that's good. That's good. That's good. That's good. That's good. Hot, 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 hot. Well, it doesn't show any signs of being destroyed. That is quite warm. Thank you. I still have my asbestos fingers from when I used to do a lot of cooking. I still have some videos on YouTube here someplace of me cooking. They weren't very good. Okay, so there's no insulation at all. All right. Went and got one while that thing was heating up. So we'll put this back on here. Maybe. Maybe not. Well, it had Loctite on it, unfortunately. A lot of it. Not the blue stuff. It was almost clear, but boy, was it. Okay, come on, fingers. They're not really behaving today. Are there easier ways to do this? Yeah, probably. Got to get this centered because there is a key for that heatsink to go through the board in the back. All right. Cool, you really can't do it wrong. That's nice of them. All right. I really don't know if this is going to fix it completely or not. And it kind of bothers me that that this went bad and it evidently hot. Of course, this being prosumer gear, this was in service 24/7, and it's not really designed for that. It's designed to be set up on stage or whatever and used for a while. And they have there's no cooling in this. There's no fan, no nothing. So, I don't know. How are we looking? Looking good. Just going to do a cursory inspection here. And I'll tell you what, I'm going to check these caps just for the fun of it. We're going to do them in circuit. Well, for the fun of it, just to see how bad they are. I've come to more or less trust this little guy. This blue ESR tester. Okay. It seems to be about right. 0.9. Live with that. 1. Can live with that. Way over. No. And no. Okay, so those two don't look so healthy. How about these guys on the outputs? Come on, fingers. 0.5. 0.4. 0.4. 0.1. And 0.75. So the only ones that don't look too good are these guys. Well, let's remove them. See what they look like here. They appear to be good quality caps. Little goo in here. I do not just arbitrarily go through and replace everything for a couple of reasons. One of which is really not necessary to just shotgun everything and go through, order all the parts and build a new power supply. It's just not necessary to do that. And two, removing parts from a board, no matter how well built the board is hard on the board. It just is. If you can keep from just willy-nilly changing parts, that's one thing. Now, if you've got something like an old, boy, I hope that was marked which way was plus and minus. It is, good. Like an old 50-year-old piece of gear or a 75-year-old piece of gear, yeah, it's probably a good idea to just go through and redo it. But this isn't that. And the parts appear to be pretty high quality. Well, let us take a look and see what these say they are. They didn't look good in circuit. Okay? Just saying. Taking a long time. It says 36 picofarad. Really? Try that again. .34 picofarad. Toast. We're going to check it on another meter just to be sure, but that's not a good sign. Here's the other one. My fingers are kind of across it. And it's just going to say close to the same thing. It may say nothing. It's not even going to measure it. Oh, wait, there goes 36 picofarad. That is default because of leads. Well, for fun and kicks, let's put it on this guy. These are supposed to be 220 microfarads at 25 volts. If you watch my last video, I did a comparison of all of these things, these capacitor meters, and what each one is actually good for. We'll go through this guy. Okay, this is saying 3.8 microfarads on this meter. And this meter just reads basic, and it does it at a fair, and this is saying point. No. All right, well, let's get the good meter here. And we'll test it with this. Unfortunately, this one requires power. Like 12 volts. Good enough. All right. I don't know if you can see this or not. Well, put it on caps. Put it on 100 cycles. Hertz. I'm old. Okay. And hook it up. Let's see what it says. Okay, it's saying 1.9 micro. Okay, so 1.9 microfarads, or 1900 nanofarads, 2.9 or 3 kiloohms ESR, and a phase rotation of minus 15 degrees. That's called, no, that's called shot. That's no longer a capacitor. So, I don't know what that is. That's reading different on all three meters, but all three meters say, yeah, it's no good. So, we shall be replacing those. The other ones attempted there looked like they were okay. I gotta figure out a way to put some. Hang on. Oh, so we want what? 220 at 25. What have I got here? I'm going to stick these 470s in here just for the heck of it. And see if it makes any difference. Because both of these are filter caps. They go to ground. And in this particular instance, I don't think it's going to make much difference. So it's on the plus and minus 15 volt side is where those caps are. I don't think adding a little capacitance to it is going to mess it up on the output like this. Kind of makes you wonder why they got that 220 and then they also got 100. Because these guys out here, these are 100, and they are attached to exactly the... No, they're not. These are the inputs. Okay. So I still don't think it's going to make much difference. If it does, I'll order some caps and put them in, but I really don't think so. Okie dokie. Well, let's see. Let's kind of plant. That's nice. It's got the little things where it goes in there. I actually have they go right into the board so that it'll stay. That's kind of cool. All right, let's screw this down. Temporarily. Good enough. That one says ground, so that's important to get in on there. All right. Let's get you on some sort of grounding somewhere. Yeah, that's good enough. And you on there. All right. We're off. And bring it up on the light bulb. Nothing. Voltage. 15.14. Negative 15.08. Still got our 5 and 3.3. Well, that means it should be saying something in the front. And ta-da! There it is. Now, I have no idea how this works, but it appears to be working just fine. We'll have to hook it up and do something. Hang on. Got to put this back together a little bit. Yeah, right. Oh, here. Off. Like I said, I didn't think that putting a little extra capacitance in there was going to hurt anything. We'll run this for a while, and we'll also take a look and see how hot that gets, because that kind of bothers me a little bit, just hanging out there in the breeze with no cooling. Tepid coffee. Okay, let's put the power supply back together again. Well, maybe this one will just turn out to be an easy one. That would be nice. That's not the right one. That would be nice for a change. Because I get... No. Did I put the wrong screw over here? This one over here, maybe? Yes, I did. I seem to get a lot of real pain in the neck repairs of things that are just strange. I don't know if I'm going to do a video on it because it would be a 27.5-hour video. But I had a ICOM 471, 440 all mode rig. That was just drove me nuts. It would work, but only at half power. Everything in it looked right. I mean, I checked the... Oh, come on. There you go. I checked all the transistors and the outputs and the little brick that creates power and went down the rabbit hole for many times. and finally took out the power output transistors to test them out of circuit, which I don't like doing because it just tears up the board and all the little pieces, parts that are connected to them. And I found out that one of them was actually leaking, but only when you applied voltage. Collector emitter. Weird. Not seen that one before. All right, so you're back in. You're good. You're good. All right. Okay. How can I do this easily? Speaker. Put you up there. Okay. So I need an output here. Let's figure out how to do this. Someday I will come up with a better method of doing this. All right. So this is my output. Let's, there. Here's my input. There. Well, we'll go on and see if it's just passing audio at this point. So this, and this. This. What an interesting way of doing things. Okay. Off. Okay. Got yelled at by somebody about not turning stuff off or seeing it, but it's over here and you can't really see it. So. All right. On. Well, it passes audio. We can hear that. The lights are working. Well, we're going to have to feed it something on the order of sound. Well, let's see if this guy works. It appears like it does. How am I going to do this? Kludge something together. Kludging away. Ah, no, I don't need to do that. Don't need to kludge. I don't think. This here to input. Yeah, I'm going to have to do the same thing. So I need to go to this, Well, think. Hold on. Okay, well, I sort of got it all kludged together here, coming out of my this little guy. It's what is this thing? It's a little old Samsung MP3 player. And I got some stuff off the web, off of, what do you call it? To play, so I won't get hit with anything. Copyright stuff. So, let's see. Got it on 3. It defaulted to number 3. If I could pull this up for you here. Let's get this started. And I got it plugged into a little amplifier over here on some speakers. Okay. I got it turned down. Let's see what happens. Oh, yeah. XL Halls. Let's see. Stereo Hall. Let's try that. Yeah. Okay. These... Well, it appears to be working. Not that I know how to use it. Ooh. At all. Let's see. Dry field background. These are all factories. Vox bleeds slap room. Boy, it's all kinds of decay settings. This thing is really complicated, and I don't have time to read the book. I don't like that song. What's that? Ping pong and hall. Yeah, it's working. But what I want to check here is I don't like this. That getting hot. And I want to see how hot that gets, because that little bitty, I mean, they designed it. I suppose they know what they're doing. But that little bitty heat sink seems rather wimpy. So, come on. Where are you, Fleur? And turn you on. This takes a minute for it to come up. That's okay. We'll turn this sideways just a little bit. Exit. Yes, it's on. You know it's on. Do your thing. All right, here we go. Let's take a look over here. Bring you down so maybe you can see this a little better. All right. There is that. Wow, this is going to be a lot harder than I thought. Let's see. What's getting hot? Okay, there is that heat sink right there. So what is getting so hot? There's this guy. That's not hot. There's this guy. That heat sink's not too hot yet. Ah, right there. Yeah, so 62 degrees C, 63 degrees C. Let's get a different. I don't like that color. Too much color. Well, it's sitting there at 63.6. That's not terrible, I guess. Yeah, I guess that's okay. Not horrible, but still looks kind of wimpy. All right, guys. Well, yeah, it's crooked. Of course it is. There. Well, it appears to have fixed it. That is pretty warm. I'm going to let this run for a while, and if I need to, I'll put another. I mean, there's a reason for that thing being that way. I mean, it's because it's drawing so much current. The 15 volts runs everything in here. Let's see what kind of current it's drawing. Well, just on the board, it's drawing about 170 mils on there. The minus 15 is drawing 140, so that's not it. So it drives, that plus 15 drives this display up front and everything else on the front panel. Capacitors are not hot. Well, I don't know. I'll let it run for a while and see how hot that thing gets. If it gets blindingly hot, I'll replace it. Does this bypass? No, it does not bypass. All right, well, anyhow, there we go. Pretty simple repair. Lots of screws. And just this guy here being wimpy heatsink. Okay, hi, I just had to jump back in here. I've had this thing going for several hours now, and it's working just fine. Nothing wrong with it at all. It works. Everything's great. However, I wanted to show you all something that I disagree with vehemently. Well, first things first, this voltage regulator over here got really, really hot. I mean, hot, up in the like 175 degree mark or someplace like that when it was on for a while. So I stuck a little extra heat sink on top of here. One of those ones that you get in the kit, like this kit of heat sinks, you know, with the sticky stuff on the back of them. And measured it and ran it for a long time and put it on the meter. And it goes up to about 125 and stays there now. So that's good. I can live with that. That's fine. That's not enough. But remember when I said this thing was not meant to be used, designed to be used in the service where it's on all the time, 24/7. Well, guess what, folks? I want to show you this. And this, really? I mean, this is just really. Okay, now I'm going to turn it on. It's on. Okay, see? And we're going to take a measurement of voltages here. We'll put that guy there. And the meter's not reading. Why is the meter not reading? Come on, start. All right. There's your meter. And we're going to measure our voltage. Here is minus 15 volts. Here's the plus 15 volts. I'm going to turn this thing off. It's off. It's off. No touching buttons. There's 15 volts. There's 5 volts. There's your 3.3 volts. This thing is off. So even if this is off, this power supply is continuously on. Always. Never goes off. Now, I'm going to flip the switch to turn off the unit itself, and there goes your 15 volts. That is despicable. This thing's drawing current constantly. Matter of fact, how much, just for the fun of it? Running all by itself. 4.2 watts off. 9.3 watts on. So, folks, you guys who built this thing, really? You leave a switch mode power supply energized 24/7 if this thing's plugged into the wall. No wonder the capacitors blew up over here. And this isn't going to get hot when it's turned off because it's not drawing enough current, but really? Just really? Here, let's turn it off. Put my meter here. These things are better than sliced bread, by the way. Go to DC 0. So it's drawn 53 mils on that line. When you turn it on, it draws 160. So a full third of its current, it's constantly just drawing it just because it's plugged in. I don't like that. I don't like that at all. But I didn't design it. Wow. And I'll bet that's what took it out, sitting there running forever. Anyhow. Hey, thanks for joining me at the bench. And don't forget to subscribe, ring the bell if you want to see more of this. Till next time.